this should feel familiar because all this is, the only difference between this one and the previous time we did this example is this one is about, this one we're doing a confidence interval to make our decisions, okay? So the first thing we want to know is this independent or dependent? Like kind of going through what I'm going to ask myself in order to answer each question here. Independent or dependent? Z or T? So if you guys recall, we took a sample of 41 calls going to an overseas call center and 50 calls going to a U.S. call center. Okay? So independent or dependent? Independent. Okay. The minute I choose independent, that tells me that whatever I'm doing is going to be a 2-sample interval. Whereas if it's dependent, that tells me I'm going to be doing 1 sample. Okay? That's why I'm kind of going through why we ask ourselves each of these questions. Z or T? Do we have the population standard deviations? I always have to go back and say, a sample of 41 calls had a mean time. In fact, that 5.2, that's describing the sample, not the population. Okay, so this is T. So that tells me I'm picking 2-sample T interval in my calculator. So hopefully you guys are seeing like why we care about independent versus dependent. Okay, and if I go to that 2-sample T interval, so that looks to be option 0. This time we're doing it from the summary stats. Looks like I have it in from the last time I worked this question, but I'll give you guys a second to get it typed in. It is worth noting that because I put for my X1 and N1 and S1, all of those was, so as I'm typing this in, this interval is for US minus overseas. Like the order we put that in matters, so we want to make sure we're paying attention to which one's which, because at the end of the day, if it's all positive, the U.S. call center lasted longer. If it's all negative, the overseas, like we need to know the order of that subtraction. Okay? Remember, we always choose unpooled. Guys, I got the interval to be negative 3.95 to 0.57, or 0.75. Ooh, Meister screwed up. The confidence level. The confidence level should be 90 because my picture, my test would be a one-sided test with alpha equals 0.05. So the confidence level would have to be two-sided, 0.9. Totally screwed that up. So that shockingly makes my interval narrower, right? And that makes sense. Less confident. And then the difference in means, of US minus overseas is between So, is there a difference between if the calls are routed to the US versus overseas based off of our interval? Is there a difference? What would happen if there wasn't a difference? What number is the difference if there isn't a difference? 0. Is 0 in the interval? Yeah. So can we say conclusively that there is a difference between the two populations? No. Because 0 being in the interval means it's possible that there is no difference. Everybody good? All right. Just because I'm going to put this in the recording. Okay. So like I said, we're going to do this example, and then we have one other example we kind of skipped over that if we have time we're going to do. Because I will not be here Tuesday or Thursday, so I want to make sure we're all on the same page in terms of what I'm going to be expecting out of you guys. Tomorrow during class, you're doing Lab 9B. It's similar in length to Lab 9A. It's because it's one where the spreadsheet's already got all the data and stuff in it. You just got to do something with it, okay? So you theoretically, that is going to be due on the 17th. So a week from Thursday, okay? On Thursday, you'll have the class period to work on the Unit 9 homework. Okay, so both days are work days on stuff. Okay. That is also due on 4/17. Everybody good? Okay. So in this particular example, we have a group of students taking both a pre-test and a post-test. So as we look at, say, this one person, are we allowed to directly compare that 0 and that 2 if they came from the same person? Yeah. So would you guys call this independent or dependent samples? Dependent. Okay. So what we're going to do is this time what we're going to do is a confidence interval for mu D. So let's go ahead and make our confidence, we can choose the order of our differences. My experience with students is that you guys prefer positive numbers over negative numbers. Okay, so let's do post-test minus pre-test for these particular set of students. Okay, that's going to be our differences. So we're going to kind of create this other row. And what we're going to do for each student, let's go through and do what is their post-test score minus their pre-test score. So as I look for this first person, I would be doing 2. They went from a 0 to a 2. So 2 minus 0 is 2. And then 3 minus 0 is 3. For the next student, that 3 minus 1 would be 2. So we're basically saying what happened to their score. If we do post minus pre, then if it's positive, their score went up. And if it was negative, their score would go down. Everybody good? So let's kind of go through and do that for each student here. How are we feeling so far? Okay, now to do our interval, we're essentially going to be estimating the mean difference. So what we'll need to do is throw that into the list in our calculator. So All right. Now, how many lists or how many means am I running this estimate for? Like I have 3 lists of numbers, right? Okay, but the only one I'm actually interested in, like this 2 right here, is not actually what I'm interested in. I'm not interested in just their pretest scores. And I'm not interested in just their post-test scores. Like what I care about is that one number for that one student, which is how much they improved. Is everybody with me? So I have to decide first and foremost, Z or T. So let's start with Z or T. Which one do I want to do? Why T? We're not given the population standard deviation anywhere. So the first thing I know is that I'm going to be doing a T interval. And then I have to decide, do I want to do a 1 sample T interval or a 2 sample T interval? But when we think through the list of numbers that we're dealing with here, we don't want to be looking at each, the pre and post test separate. We're looking at the improvement for each kid. Is everybody good? So we want to do a 1 sample T interval. There isn't a 1 sample, it's just the T interval. That's what we're picking in the calculator. So go ahead and hit stat. You're going to arrow over to your tests. And option 8 is that T interval. In this case, what we have is the raw data. I stored mine in my L1. And I'm going to change my confidence level to 0.95. Are we all on the same page here? So my interval for my calculator is 1.692 to 3.507, or 508, and that's how that would round. And what does that estimate? What do you guys think? What is that estimating? In some respects, that's how much the scores changed, right? Like each of the numbers that came from was a change in score, an improvement in score, okay? So we could say a mean improvement between 1.692 and 3.508 points. That's what the average improvement was. The average improvement of the students as a whole is somewhere between 1.7 points and 3.5 points. You feeling okay? Okay. Can we say with certainty that the students made progress then? Why? Because the entire interval is positive. Post scores are bigger than pre-test scores. Are we feeling okay? All right, we had one other example that we didn't get to a couple pages back.